The second part of physical properties that we're going to look at is going to be the density. So we're just going to kind of do it similar to what you would have done in general chemistry. So we're going to do the density of octane as well as dichloromethane. So let's move the methanol out the way. So we have octane and we have dichloromethane. You'll see that the chemical formula for dichloromethane is CH2Cl2. We can also call it methylene chloride. So these are just different names that we can use for the dichloromethane. So again, we need to look at the CRC to find the values for the dichloromethane. So I'm going to bring you here to the CRC again, and we're looking for, the first one we're going to look for is dichloromethane. So we keep searching, and voila, we found it, methane dichloromethylene chloride. So its compound number is 9060, and we want to find the density, which is 1.3266. And these densities are taken at 20 degrees Celsius. We want to do the same thing for octane. And that page number again was 349 that the dichloromethane was on. We want to do the same thing for octane. So octane is on page 381. So that's C-381. We want to look for its compound number, which is here. So its compound number is 10027, and we want to find the density, which is 0.7025, and again it's calculated at 20 degrees Celsius. So initially when we plugged in the LabQuest, you'll notice that we have that initial temperature, which was 23 point something. I believe it was 23.1. But you can look at that temperature at the very beginning of the experiment where we did the melting point. Also, when we look at Aldrich, Aldrich tells us that the CAS number for the dichloromethane is 75-09-2, and the Aldrich value for the density of dichloromethane is 1.325 grams per milliliter. When we look at Aldrich for octane, it tells us that the CAS number for octane is 111-65-9, and the density that corresponds to octane for Aldrich is 0.703 grams per milliliter. So what I'm going to do is take a pipette, and I'm going to take a pipette bulb, and I'm going to gently put the bulb on. I'm not going to jam it in so that I have a lot of space to squeeze in order to get the liquid inside of the pipette. So I'm going to just bring you back slightly so that you guys can see what we are doing. Let's see, I may have to put you up and bring you closer. So hold on one quick second. All right, so that should be better. So I'm going to take a graduated cylinder, and I am going to take the mass of it. I'm going to put it on the balance. So I'm going to bring you to the balance, and you'll notice that our balance is zeroed out. So we want to go ahead and open the door, and we want to take our graduated cylinder and we want to put it on the balance, and then we want to close the door. We want to look at the balance, and we want to wait for it to stabilize. And here we have the mass of just the graduated cylinder. We're going to remove the graduated cylinder. Close the door. And we're going to start with the dichloromethane. Which is here. And I'm going to take our pipette and I'm going to transfer a certain volume to the graduated cylinder. I'm going to take the graduated cylinder, I'm going to add just a little bit more so we can have roughly 1 milliliter. I'm going to come here and we have our solvent inside and we want to read the meniscus of that graduated cylinder. Let's see. I'm gonna give you guys, let's see, a white background so that we can read it. And I know for you guys it's gonna be hard to read, so I'm gonna read it out for us. So it is 1.41. So the volume is 1.41 milliliters. Again, the volume is 1.41 milliliters. Again, we want to zero to scale the balance. Open the door, and we're going to put our graduated cylinder with the dichloromethane. And we're going to wait for the balance to stabilize. And here we have the mass of the graduated cylinder and the dichloromethane. The same thing we just did for the dichloromethane, we want to do for the octane. So I have a new graduated cylinder, a new pipette bulb. I'm going to close the door on the balance to calibrate the balance. It is now at 0. I'm going to open the door, put the graduated cylinder in. We're going to wait for the balance to stabilize. And now we have the mass of the empty graduated cylinder. I'm going to remove the graduated cylinder. And the way that you would use the pipette bulb, you would depress first, and then you would stick the pipette inside of the liquid. You would let the bulb go, you would depress, and then you would put it inside of your container. So again, I'll read the mass off for the the volume, sorry, for the octane from the graduated cylinder. So the volume for the octane is about 1.48. The volume for the octane is 1.48 milliliters. I'm going to open the door to the balance, put the graduated cylinder on, close the door, and now we can take the mass, once the balance stabilizes, of the graduated cylinder and the octane. Again, this is the mass of the graduated cylinder and the octane. So that concludes the density portion that we had for the methane, the dichloromethane, and the octane.